Hello everyone, welcome back to Chemistry 24x7 series. In this series, we have been exploring the solution for previous year competitive exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. So in continuation of our heck related problems, so this is also a heck problem. So this is the question from CSIR 2024. As per this question, this dihydrofuran derivative react with 2-naphthyl iodide in the presence of palladium acetate, triphenyl phosphine, silver carbonate in acetonitrile, which produce a product. So here there are 4 options are given. Let's all together to find the correct option for this question. So before moving to the solution, so we have already discussed Heck cross-coupling reaction and their mechanism and catalytic cycle and their related problems. If anyone missed that video, you can find the link in the description box below. So as per Heck cross-coupling reaction, the first step of the reaction will be a generation of active palladium zero catalysis. Since this reaction requires palladium zero catalysis. So now you see that. So for our convenience, we can rename that triphenyl phosphine as L. So now you can see that. So initially the generation of this palladium complex, then followed by ligand dissociation that generate palladium zero catalysis. So after that, which react with 2-naphthyl iodide. So for our convenience, you just rename that this ring system equal to 2-naphthyl. Now which undergo oxidative addition with this palladium zero catalysis, which produce this corresponding palladium complex. Now this palladium complex react with silver carbonate. So here you can see that silver carbonate react with this palladium complex. So resulting that generation of silver iodide precipitate. So along with generation of this corresponding palladium cationic complex. So if you're familiar in Heck reaction, so there are 2 type of mechanisms are known. So one is neutral mechanism and another one is cationic mechanism. So sometimes people use cationic pathway, especially if you use electron rich alkene or if you want to accelerate the rate of the reaction. So at the time you need silver based additive which dramatically accelerate the rate of the reaction. So in the case of our reaction, so this alkene is electron rich alkene. So therefore here they need silver carbonate. So after the generation of this palladium cationic complex, which then undergo pi complex formation with this corresponding dihydrofuran. So this is a crucial step in this reaction since here involved with stereochemistry. Now you can see that this substrate phenyl system present at the bottom phase. So therefore our palladium complex should interact with this alkene by top phase. So resulting that generation of this corresponding palladium pi complex. So now the next step of the reaction will be a carbopalladation reaction. So here also we need to sort it out regioselectivity. So here we need to think about where this palladium should move and where this 2-naphthyl ring system should move. Since here you can see that 2 positions are there. For that we need to think about electronics of this alkene. So here you can see that oxygen has lone pair of electron. So therefore that lone pair of electron should go here. So resulting that this position is electron rich position and this position is electron deficient. We know that palladium center is electrophilic center. Therefore palladium should move to electron rich carbon. In case of 2-naphthyl system should move to this carbon. This is a electron deficient carbon which produce this corresponding palladium complex. So at the same time carbonate base that coordinate with palladium should generate this corresponding palladium complex. So the next step of the reaction will be a syn beta hydride elimination. So now you can see that. So this is the beta carbon as well as this carbon also beta carbon. However, this beta carbon hydrogen atom not perfectly aligned with this palladium center. In case of this beta carbon has 2 hydrogen atom, so definitely one of the hydrogen atom should perfectly align with this palladium center, which then undergo syn beta hydride elimination to produce this corresponding alkene as a final product. At the same time, the generation of this corresponding palladium complex, so which then undergo reductive elimination to produce bicarbonate ion with the generation of palladium zero catalysis. Well, let's moving to the our question. So as per our discussion, among the four answers, the correct option for this question is option 1. That's it for today's problem. I hope this video has helped you to understand Heck coupling reaction and cationic mechanism, and followed by stereochemistry and regioselectivity involved in this reaction. If you enjoyed this session, just give it a thumbs up and share it with your friends, and don't forget to subscribe ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.